Yeah. So here we are. We just set up our wireless sensor, transmitting all our data to a dashboard, which I will show you in a second. Now what we have is inside under that gauze, it's a high temperature glass. We have a fixed load, 10 ohm resistant load. This unit is basically a test unit that we will put into a yard for a year and test it under real conditions. Here's the unit here. It's rated at 15 watts. It will be running a servo in the field, a 5-volt servo. We are charging it, and we have a fixed load in there right now only for testing. So we have a very a fixed resistance. So it'll only produce what the load requires. As you can see, the dashboard, and actually the LCD that we have, is displaying a cycling inputs. Right now we got voltage in at 15 volts, and we're producing 5.11 watts, which is again our fixed load. We don't want it to produce anything more than that at this time. That's our load factor. We can increase the wattage. We just don't need to for this test. The actual potential of the system is 15 watts. We're just not running at full potential because the client wants to run it at a predetermined charge rate, which will charge this battery in the field for them. It's a 50-watt battery, and it will maintain a system that's got a predetermined load, and you should see it transmit very soon. This is a 900 megahertz, which is not quite installed yet. We'll install it. We're just testing it right now, but we will install it very soon. There, just transmit it. All the data, all the sensor data that you see scrolling through the board. That's the thermocouple on the hot side, 189 Celsius. That's a thermistor on the liquid. L is 28 degrees Celsius. The thermistor outside, that's the temperature inside here, is 13.8 Celsius. The liquid level is 50-50 glycol water, good to minus 50 degrees Celsius or Fahrenheit. And those towers here are filled up to roughly about here with glycol water mixture. We have cooling towers on top. You see the thermistor for the liquid going in, and it also measures the liquid level. The sensor goes down about this far. It has a thermistor on it. You can see the sensor here. This is a typical sensor. We have the thermistor, which you see here at the bottom, epoxy sealed, and then the liquid level, as you can see here. And that is what you see here. And that gives us two sensor readings, both temperature of the liquid in the cold side and also liquid level on the cold side. You can see we have a window to show the internal flame, roughly about 10,000 BTU burning. We don't want to get it any hotter than that. This will go up hot side to about 220 degrees C based on our previous testing, and that's what we cap it out at. And as you can see, the thermistor liquid is starting to increase while the temperature inside here is remaining at 13.8. Liquid level will continue to show 100%, as this is at full capacity. We just started running this and filled it and set the liquid level. Now again, it should transmit. Once it transmits, we'll show you the data on our dashboard. It's transmitting too. This will transmit via the cloud. There it is, transmission. So here you have the dashboard that we've set up. There's all the data coming in, transmitting via the cloud and down to us, so we can be anywhere in the world and read the parameters of the system. And here you have all the parameters you saw on the LCD on the unit, all showing on the dashboard. And as those are documented, we can do graphs and anything else. Plot all these numbers over a year to determine power output and everything, including humidity, liquid levels, ambient temperature, cold side temperature of the tower liquid, hot side temperature of the heat sink, and power output, voltage amperage, based on our set resistor that we've placed in the unit for testing.